Hello guys, this is Channel Sonat Yadav and this is my AAT Tech Talk. This is the AAT Tech Talk for my subject data structures. The topic is a shortest path 3 approach for routing in space networks. The shortest path 3 approach for routing in space networks. The new space era is bringing deployments of thousands of network assets in near Earth and deep space. Delay-tolerant networking protocols and algorithms such as contact graph routing are state-of-the-art technologies certainly capable of achieving this ambiguous objective. Nevertheless, in this paper, we highlight and analyze the roots of current scalability limits of CGR to propose more efficient alternatives. In particular, we leverage a different graph modeling approach that enables optimizations such as priority queues and spanning tree searches in one core route determination process. While such abstract data types are difficult to adapt to CGR, we incorporate them into a novel, shortest path tree approach for routing in space networks, which is presented as a commute efficient alternative. This paper thoroughly describes the SPSN approach including route object modeling, capacity-oriented search, and potential route management techniques. Prototype evaluations analyzed in this paper present significant evidence that SPSN outperforms legacy CGR in more than an order of magnitude in contact plans comprising thousands of contacts. Keywords delay-tolerant networks, contact graph routing, scheduler-aware bundle routing. The autonomous transmission of information through Internet has changed the lifestyle on Earth. The benefits of extending its advantages into spaces on this point. During the first decade of the 20th century, the space community advanced enabling technologies such as information flying and efficient inter-satellite communications. Most of these efforts enabled significant reductions in components, weight, size, price, and lead time. The materialization of satellite constellations now being pushed by several private companies and evidence of the achievements. Uh, the realization of space internet that bridges ground between the Earth and deep space assets is imminent in this context. However, fundamental environmental challenges need to be considered in place, right? The orbital dynamics, the varying and very long range communication distances, and the effects of plane rotation and on-board power restrictions result in prolonged episodes of disconnection. Furthermore, the propagation delay of signals in deep space and interplanetary environments is generally in the order of minutes, hours, or even days. The resulting delay and disruption conditions prevent the optimal operations of traditional Internet protocols, which are largely based on effectively instantaneous flow of information between sending and receiving nodes. Instead, delayed torrent networking, which assumes no instantaneous feedback but potentially lengthy storage of data and intermediate nodes, has been proposed to overcome these issues. At critical aspects of DTN architecture is the routing of data. In DTN, it is not possible to use traditional routing schemes based on stable connections. However, it is possible to sure, which may be expressed as a contact line indefinite in the expected resources that the space network will have for transporting data. In this work, we propose a radical improvement based on a different underlying Mode 1 novel algorithm. like approach that reduces the computation effort. We introduce an outperforming shortest path tree strategy called SPSN. It combines the calculation of routes to several destination nodes in a single algorithm execution with the utilization of traditional node to vertex graph model. The result shows that SPSN reduces computation time in several orders of magnitude with respect to the current CGR, especially for large contact plans. Background: CGR route search procedure and adaptation of Dijkstra's shortest path algorithm sits at the core of CGR. Goal is to find a route to destination from a source node lying on so-called contact graph data derived from the contact plan. In a contact graph, each vertex is a contact directed edge, a period of message retention, if any. However, in practice, its adjacency annotation is replaced by contact a selection procedure. The main argument to process the contact graph this way is the incompatibility of the original DSPF with time-varying graphs or multigraphs. Overview: Algorithm: SPSN emerged from the combination of two core improvements to the legacy CGR and DSPA. The first enhancement permits the calculation of the best routes to each vertex in the network during a single DSPA run. The second improvement is to replace the contact graph with a traditional graph. The base idea is simple. During the search, if a vertex has to re-evaluate the distance to another adjacent vertex, if this adjacent vertex is accessible via multiple edges, only the edge having the minimum cost matters to possibly find the lowest cost hop, while the others can safely be omitted. With a nodes as vertices approach in SPSN, the distance of a vertex from source in the graph is the arrival time, such as in CGR form, which leverages a vertex as contacts model. However, SPSN allows for a simpler method to sort the contacts using just the start time. Curiosities: it is worth mentioning that the approximation that W is a constant is accurate as long as the network doesn't show topological curiosities, that is, the graph is homogeneous. We show by example that topological curiosity occurs when searching a path from A to C at t is equal to 0. In a three-node network where the very first contact A and B starts at t equal to 100, potentially hundreds of contacts from B to C between t is equal to 0 and t equal to 1000. One extra contact from B to C starting after the t equal to 1000. This scenario resembles sending a message to a distant planet where an orbiter experiences several intermittent contacts with a remote base station before the reception of data. So this is the algorithm. Here we go. Multigraph MG. So is a local time T1 solar bullshit. For node belongs to MG. Do node RT routing object. All this bullshit. So is the code. I'll let you check it out for a while. चलो मेरे को वर्ल्ड कप देखना है इसको देखा कल route search. The first evaluation verifies that SPSN is able to find the same routes that CGR while we compare the time required to complete the process. Figure 3 shows the average processing time for both SPS and CGS are unique from CGS domestic cars, while the network sizes scale up to 2,100 contacts on average for 15 nodes. These results should be moderated by the fact that CGR in practice, etc. etc. Conclusion: in the new space trend is already bringing the deployment of large-scale space network missions, with thousands of near-Earth and deep space assets are expected to be connected in the upcoming years. The state-of-the-art routing approaches for delay-tolerant networking technologies and how enabling this connectivity heavily relies on CGR. In this paper, we have pointed to scalability limitations of CGR, detecting its algorithmic roots, and proposed an alternative outperforming approach on by space and replaces contact graphs which enables the utilization of current algorithms improvements such as priority queues. Thank you. That was my tech talk and hope you like it.